Okay, today we're going to be looking at the final exam review. I'm going to quickly go through all the problems on this review. Start with 1. We want to evaluate log base 4 of 105. Okay, so if you recall, the way that you evaluate a logarithm is using the change of base formula. So we would do the natural or the common log of 105 over the common log of 4 and calculate it this way. Okay, so let's do common log of 105 divided by common log of 4, and that gives us, it says round to the nearest 10 thousandths, 3.3571. Number 2, solve. 5 to the 2x minus 12 is equal to 72. Okay, so this is an exponential equation that we are trying to solve. The first step here is to get the exponent part by itself. So we got 5 to the 2x is equal to 84 if we add 12 to both sides. And now we change this to log form. Okay, so this is log base 5 of 84 is equal to 2x. We can solve this for x by dividing by 2. So we got x is equal to log base 5 of 84 over 2. And then we can calculate this in a calculator by using the change of base formula. Log of 84 over log of 5, and then that gets divided by 2. So log of 84 divided by log of 5, and we need to divide that by 2. So that gives us x round to the nearest 10 thousandths, 1.3765. Number 3, solve. We have x over 4 minus 7 over x equals 3 over 4. So this is a rational equation, chapter 8. We would solve this by finding the LCD. The LCD in this case, lowest common denominator, would be 4x. So we'd multiply this by x, this by 4, and this by x. That would give us x squared over the LCD minus 28 over the LCD equals 3x over the LCD. And we can just combine these into 1. X squared minus 28 over the LCD equals 3x over the LCD. And then we can just ignore the LCD. We have x squared minus 28 equals 3x. Now we solve this equation. This is a quadratic. Okay, so the way that you solve a quadratic, because it has an exponent of 2, is by setting it equal to 0 and then factoring. So this is x, so we have to move the 3x to the other side by subtracting it. So x squared minus 3x minus 28 is equal to 0. And then we factor this by finding two numbers that multiply to negative 28 and add to negative 3. That's negative 7 and 4. So we have x minus 7 and x plus 4, and their product is 0. All right, so the numbers that make the factor 0 for this factor would be 7 would make that factor equal to 0, and for this one it would be negative 4. So we actually have two solutions here. We just need to check to make sure that they both work and they're not restricted values, meaning they would not cause the denominators to be 0, and the only number that would cause the denominator to be 0 in the original problem is 0, so both of these are solutions, 7 and negative 4. Number 4, find the sum. Okay, so we just need to add these together, which means we just need a common denominator. So our common denominator here would be 6. So we'd have to multiply the first one by 2 and the second one by 3. So we'd have 4x over 6 plus 15y over 6. And now they can be combined over a single denominator, 4x plus 15y over 6. Number 5, which of the following represents exponential growth? Letter A is linear, that's a linear equation. This one's a cubic equation. Both of these are exponential, but for it to be growth, the factor needs to be larger than 1. The factor here is 1/3, so that's decay. So the only one that exponential growth is letter C. Number 6, what are the coordinates for the hole or point of discontinuity? All right, so first of all, let's take, looks like we'll be using this for a couple of questions. So x squared minus 9 over x squared plus 2x minus 3. So numbers 6 through 8. Okay, so let's go ahead and factor the numerator and denominator. So the numerator factors into x plus 3, x minus 3. The denominator factors into x plus 3 and x minus 1. All right, and then to simplify, we can cancel the x plus 3, so we end up with x minus 3 over x minus 1. Now, the point of discontinuity is going to be where we crossed it off, okay, at -3. Okay, there's going to be a hole at x equals -3. That's the factor that we crossed off. So if we want to know where what the y coordinate of that hole is, we just need to plug -3 into this right here, x minus 3 over x minus 1. So the y coordinate, so we have -3 minus 3 over -3 minus 1, which is -6 over -4, and that simplifies to 3/2, or 1.5. Okay, so the hole for number 6 is at -3, 1.5. There would be a hole for discontinuity there. Number 7, what is the equation for the horizontal asymptote? So the horizontal asymptote goes left to right. The horizontal asymptote goes left to right. So the horizontal asymptote is going to be the coefficients over each other. It's a over c, I believe, is how we did it. So it's this number over this number, 1 over 1. So it's going to be y is equal to 1. Okay, it's the coefficients on the top and bottom over each other. So in this case, y is equal to 1. And then number 8, we want to know where the vertical asymptote is. So that's the horizontal asymptote. We want to know where the vertical asymptote is. So the vertical asymptote is actually where the denominator would be 0. So we can see x minus 1, the denominator would be 0 at -1. Or sorry, +1. So our vertical asymptote would be at 1. So that would be B. All right, solve the log equation. So for number 9, we want to solve the log equation. So we have log base 2 of 3x plus 2 equals 7. Okay, so to solve this log equation, we need to change this to exponent form. So if we change this to exponent form, that would be 2 to the 7th power is 3x plus 2. Remember, a logarithm is logarithm the base. 2 to what power is 3x plus 2? And that's the answer. So 2 to the 7th power is 3x plus 2. And then we can solve this for x. So we subtract 2. Well, I guess I can do 2 to the 7th, whatever that is. Let me go ahead and evaluate that. So 2 to the 7th power is 128. So that's 128 equals 3x plus 2. And now I will subtract 2. So minus 2. So 126 is equal to 3x. Divide by 3. And that gives us x is equal to 42. Number 10, write as a single logarithm. So we have 5 times the log of x plus 3 times the log of y minus 2 times the log of z. So essentially we're trying to condense this into a single logarithm, so we have to remember our properties of logarithms. So first we deal with the numbers on the outside. Those go on to the inside to become exponents. So this is log of x to the 5th plus log of y cubed minus log of z squared. Okay, now if we want to combine these into a single logarithm, then the numerators will be the ones that are added, and then any of them that are subtracted will be in the denominator. So that would be x to the 5th times y cubed in the numerator, and then z squared in the denominator. So letter C. Number 11, if $25,000 is deposited in an account paying 1.5% compounding continuously, find the balance in the account after 15 years, and we have our compounding continuous formula, A equals P times E to the RT. Okay, so this would be A is equal to 25,000, which is our principal, is what we start with, times E to the rate. Now don't put 1.5%. The rate needs to be changed to a decimal. So you need to move the decimal place over 2 spaces. So, whoops, too many. So 0.015 would be the decimal representation of 1.5%. So this is 0.015 times t, which is 15. Okay, so I can plug all of this into a calculator to calculate this for me. So 25,000 times e to the 0.015 times 15. Okay, so that gives me my final amount, $31,308.07. Number 12, Sam can sew a quilt in 8 hours. When Sam and Mary work together, they can sew it in 5 hours. How long does it take Mary to sew a quilt by herself? Okay, so we have Sam's rate plus Mary's rate equals their rate together. Okay, so Sam's rate is 1 quilt in 8 hours. Mary's rate we don't actually know, so we'll just say she can sew 1 quilt. Sorry, we don't want the X up there. We'll say she can sew 1 quilt, but we don't know how long it takes her to sew a quilt, so we'll say in X hours. However, we know that together they can sew 1 quilt in 5 hours. Okay, so if I can solve this equation, then I can see how long it takes Mary to sew a quilt by herself. Okay, so I'll start with my LCD. So my LCD here is going to be, it looks like 40x. Okay, so I'll multiply this one by 5x. I'll multiply this one by 40. And I'll multiply this one by 8x. So I got 5x over the LCD of 40x plus 40 over the LCD of 40x is equal to 8x over the LCD of 40x. And then I don't need the LCD, 5x plus 40 is equal to 8x. And now I can solve this to see how long it takes Mary. So I'll subtract 5x from both sides. So 40 is equal to 3x. Divide by 3. So 40 thirds, 40 divided by 3. I see. Yeah, so the rational equation would be this, 1 over 8, because Sam is 1 quilt in 8 hours, Mary is 1 quilt in some number of hours, and together it takes them 5 hours. So when we solve that, we get x is equal to 40 over 3 hours is how long it takes her to sew a quilt by herself. And that's about 13.3 hours. Okay, so simplify square root of negative 48 plus the square root of 75. Okay, so the square root of negative 48, we would simplify that. So we can say that that's the square root. So we need a perfect square that goes into 48. Okay, so I think 16 goes into it. It does. So 16 and 3. Okay, so we can take the square root of 16. Now remember, this is a negative here. Okay, so we do need to take the I out. So this is 4i times the square root of 3 plus, and then square root of 75, that can simplify as well because it's 25 times 3. So that's 5 times the square root of 3. So we got 4i square root of 3 plus 5 square root of 3. Whoops. 1 second here. Sorry, just a moment. Okay, so it just says simplified. These can't actually be combined because they are irrational. So this would be about as far as we can get. We could probably write the rational part first. Yeah, because it's a plus bi. That's the complex. That's how you write a complex number. So we would say that's 5 square root of 3 plus 4i square root of 3 for number 13. Okay, so number 14, we got square root of 4 times square root of 8. Well, we can already simplify that to, well, because this is square root of 4 times square root of 4 times square root of 2. Okay, so square root of 4, square root of 4, that's 2 times 2. Okay, so this part just simplifies to 4 times square root of 2. And then plus, and then we need to simplify the square root of negative 12, so that's going to be imaginary, remember, and that's the square root of 4 times square root of 3, so that's going to be 2i square root of 3. And then the next part, square root of negative 75, that's also going to be imaginary because that's 25 times 3, so that's plus 5i root 3, and then these two can actually be combined because they are both I or root 3. So this 4 square root of 2 plus 7i, 5i, and 2i is 7i root 3. Number 15, solve x squared is equal to negative 24. Okay, that's pretty straightforward. We square root both sides. We get x is equal to the square root of negative 24. We simplify the square root of negative 24. So that would be 4 times 6. And it's going to be imaginary because it's a negative. So square root of 4 times square root of 6. So that's 2I root 6. Plus or minus, sorry. Don't forget, when you take a square root to solve an equation, you need plus or minus. So this is a two answers, positive 2I root 6 and negative 2I root 6. Number 16 is just a quadratic, x squared minus 6x plus 10. And we need to solve this. So first we would check to see if it factors. If it factors, we're looking for two numbers that multiply to 10 and add to negative 6. It doesn't look like we can have anything that does that. So after we factor, we have two choices. We can solve this by completing the square, or we can use the quadratic formula. I'm just going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so a is 1, b is negative 6, c is 10. So x equals negative b, b is negative 6, so negative b would be positive 6, plus or minus the square root of b squared, so that's 36, minus 4 times 1 times 10, so minus 40, because 4 times 1 times 10 is 40, and then all over 2. Okay, so I'm going to do a little bit of simplifying here. So this is 6 plus or minus the square root of negative 4 over 2. Square root of negative 4, remember that's going to be imaginary. So it's going to be 2i. 6 plus or minus 2i over 2. And then each of these, I'm going to distribute the division to each of those. 6 divided by 2 is 3. 2 divided by 2 is just 1, so it's I. So the solution is 3 plus or minus I. It's a complex number. So yeah, it didn't look like this one could be factored, and it couldn't. We have a complex solution there. All right, solve square root of x minus 5 equals 7 minus x. Okay, so when you're doing a radical equation like this, you got to make sure the radical is by itself. You can get rid of the radical by squaring it, but that means you also have to square the other side. So the left side becomes x minus 5, but the right side is 7 minus x squared, so that means we need to multiply it by itself. Okay, so we distribute. 7 times 7 is 49. 7 times negative x is negative 7x. Negative x times 7 is negative 7x. And negative x times negative x is x squared. And this is x minus 5. Okay, so let's clean up the right side. Put it in standard form, combine the like terms. So that's x squared minus 14x plus 49. Okay, so this is a quadratic. So I need to set it equal to 0, and then I solve it by factoring if I can. If not, I'll use the quadratic formula. So I'll subtract x, so negative 5 equals x squared minus 15x plus 49, and then I'll add 5. So I have my equation becomes x squared minus 15x minus 54. Plus 54. Is equal to 0. And then I'll check to see if this can be factored, which means I'm looking for two numbers. Multiply to 54 and add to negative 15. And it looks like I have negative 9 and negative 6. Negative 9 times negative 6 is 54. Negative 9 plus negative 6 is negative 15. So I can factor this into x minus 9 and x minus 6. So that would mean my solutions are positive 9 and positive 6. Now I need to make sure both of them work. What it means for both of them to work is I need to make sure that when I plug them in, I don't end up taking a square root of a negative number. Okay, so if I plug in 9, I get the square root of 4, which is fine. If I plug in 6, I get the square root of 1, which is fine. So both of these are going to work as solutions to number 17, 9 and 6. I really shouldn't write it that way. X equals, or you can write it as a set, 9 and 6, so a set of solutions. All right, number 18, solve. So we have 5 plus 3 to the 2x minus 1 equals 22. So this is an exponential equation. We solve this by getting the exponent by itself. So I'll subtract 5 to do that. So 3 to the 2x minus 1 equals 17. Okay, and then I will rewrite this in log form. Okay, so if I write this in log form, it becomes log base 3 of 17. Okay, because 3 to the what power is 17? Well, 3 to the 2x minus 1 power is 17. And then I can solve this for x. I'll add 1. Log base 3 of 17 plus 1 is equal to 2x. And then I'll divide that by 2. So my solution, x, is equal to log base 3 of 17 plus 1 divided by 2. Okay, so I will have to use change of base formula to calculate the log base 3 of 17. So that's log of 17 over log of 3, and then I'll add 1 to that, and then I'll divide by 2. So let me see what that will be. Sorry, let me clear my calculator. So I have log of 17 divided by log of 3 and then I will add 1 to that, and then I'll divide that by 2. Okay, so we get 1.7895. That would be to the 10,000th place. Number 19, find all of the zeros. Okay, so the zeros here would be the solutions. Okay, and this is a quadratic, so I can solve this by, I would probably just want to use the quadratic formula here. Okay, it's a quadratic, so x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, so a is 10, b is negative 13, c is negative 32. Okay, so I got x is equal to 13, because negative 13 is just 13. B squared, so that's 13 squared, or negative 13 squared, which is 169, minus 4 times a times c, so that would be minus 4 times 10 times negative 32. Okay, and I'll actually be adding it because that's a negative 4 and a negative 32. So that's plus 1280. And that's all over 2 times a, and a is 10, so that's all over 20. Okay, so I will simplify this. So x equals 13 plus or minus the square root of 169 plus 1280, so that's 1449, and that's all over 20. Okay, so I don't know if 1449 is a perfect square root, so let me see if I can take the square root of it, and I cannot. So I'm going to try to simplify that and see if there's some perfect squares that go into it. So 4 does not go into it. 9 goes into it. Okay, so 1449 is 9 times 161. Now I don't know if 161 has any perfect squares, so 4 does not go into it, 9 does not go into it, 16 does not go into it. The next perfect square would be 25. 25 does not go into it. Okay, so it doesn't look like 161 has any perfect square factors. Okay, so so the square root of 1449 can be written as square root of 9 times square root of 161. So that's 3 times the square root of 161. Okay, so this would simplify to x is equal to 13 plus or minus 3 square root of 161 over 20. And that would be fine. It's not going to simplify any further than that. So those would be the zeros of this function here. Okay, solve the cubed root of 4x. Okay, so we got the cubed root of 4x minus 1 is equal to 9. Okay, so we're just going to cube both sides to get rid of that cubed root. Okay, so we get 4x minus 1 is equal to 9 cubed, which is 729. And then I just need to solve this for x. So add 1. 4x is equal to 730. Divide by 4. 730 over 4. Let me just simplify that. They're both divisible by 2, so this simplifies to 365 over 2. If you want to put it as a decimal instead, that's probably fine, but 365 over 2 is fine. And let me just check to make sure that that works. So 4 times 365 divided by 2. And yeah, 9 times 9 times 9. Yeah, okay. So just checking my work there. Okay. 21. Solve the system. Use substitution. The answer should be in ordered pairs. Okay, so if I want to solve this system, then I need to use substitution here. The easiest thing is going to be to rewrite this one in terms of y. Okay, so 4x plus y equals 7. So I will subtract 4x. So y is equal to negative 4x plus 7. Okay, so what I can do is I can replace the y in this first equation with negative 4x plus 7. So I'll replace the y in the first equation with negative 4x plus 7, and then the other side will just still be x squared minus 3x minus 5. And then I can solve this equation because it's a quadratic, okay? So I'll move these two things to the other side. So I'll add 4x. So I got 7 is equal to x squared plus x minus 5. And then I'll subtract 7. So I got 0 is equal to x squared plus x minus 12. And then I can solve this by factoring. Okay, so I can factor this because I got 4 times negative 3 and 4 plus negative 3 to make this. So this factors into x minus 4. X plus 4 and x minus 3. So I have two x coordinates here. The first x coordinate I have is negative 4 because that's a solution, and the other one I have is 3 because that's the solution. So there's actually going to be two solutions to this system. So these are the x coordinates to my solutions. The first x coordinate is negative 4. That's one of my solutions. The second x coordinate is 3. That's another solution. If I want the y coordinate, I just need to use one of these equations to give me the y coordinate. Okay, I can use this one, I can use this one, I can even use this one. And I actually think this second one is the one I want to use because it's already solved for y. So let me just plug my x coordinates into that and see what my y is. So I'll plug in negative 4 into x. So I get negative 16 plus 7. So that's negative 9. So the y coordinate for my first solution is negative 9. And I'll plug in 3 into that one as well. So negative 4 times 3 plus 7. So negative 12 plus 7. So that's negative 5. So this one is negative 5. So those are my two solutions to this system. Simplify, assume all variables are positive. Okay, so cubed root. Cubed root of 135. So essentially, I can either split this up into perfect cubes, or I can do a factor tree. Okay, I'm just going to do a factor tree for 135, and I'm going to take out groups of 3. So I know that 135 is divisible by 5. It's 5 times 27. And I know that 27 is divisible by 3. It's 3 times 9. And I know that 9... Okay, so 135 breaks up into 3 times 3 times 3 times 5. So the cubed root of 3 times 3 times 3 times 5. And then x to the fourth, x times x times x times x. Okay, so since it's a cubed root, I can take out perfect cubes, which would be 3 of the same number multiplied together. So a 3 is going to come to the outside, and an x is going to come out to the outside. So I have a 3x on the outside, and then on the inside I have a 5 and an x. So 3x on the outside, cubed root of 5x. Okay, so graph the square root of x minus 3. Okay, so the square root of x minus 3, I'm going to use a table. Okay, and I want to start with the smallest number that I can plug in that will allow me to take a square root. Okay, so I'm gonna plug in 3, because if I plug in 3, then it will give me square root of 0, because 3 minus 3 is 0, and the square root of 0 is just 0. And then I'm going to plug in the next number that will give me a perfect square under the radical. So I'm going to plug in 4, because if I plug in 4, 4 minus 3 is 1, and I can take the square root of 1. The square root of 1 is 1. And then I'll plug in the next number that will give me a perfect square. So I would need underneath the radical to be a 4. So I would have to plug in 7, because 7 minus 3 is 4, and the square root of 4 is 2. Okay, so this should be enough points. I have 3, 0. I have 4, 1. And I have 7, 2. Okay, so that should be enough points. I'll connect the points there. And this is a square root function. Just looks like a little curved arrow. And it stops here. Okay, it's not going to go any further than that, because then you're taking square roots of negative numbers. Okay, now it says to graph the inverse. Okay, so the inverse would have me reverse the x and y's. Okay, because remember, when you do the inverse, when you do the inverse function, it should bring you back. Remember, the inverse function is reflected across the line y equals x. So the x coordinates and the y coordinates would switch. So I would have 0, 3, 1, 4, and 2, 7. So if I want to graph the inverse function, I'd have 0, 3, I would have 1, 4, and I would have 2, 7. The inverse function is over here. Now remember, the inverse function is reflected across the line y equals x. So if you draw a diagonal line, the inverse function is reflected across the line. And then it says write the equation for the inverse function. So this is f of x, this is the table for f of x, this is the table for f inverse of x. Remember, the inverse function is very easy to write the equation. You just to write the equation for the inverse function, we write the equation, y equals square root of x minus 3, and then we write it again, but we switch the x and y, so x is equal to square root of y minus 3. And then we solve this for y. So first we square both sides, so we got x squared is equal to y minus 3, and then we add 3 to both sides, so we get y is equal to x squared plus 3. And that is, and then we rename it so that it's the inverse function. So the inverse function is x squared plus 3. And it's actually only a piece of x squared plus 3, but that is the inverse function. There is actually more of it that goes over here, okay, because it's a quadratic, so we only see half of it. But yeah. There were 2,000 people living in a small town. The population started to decrease due to a mysterious and deadly virus. Here's the function. By what percent was the population decreasing by each year? Okay, so essentially the rate is going to tell me what percent it's decreasing by. So what this is telling me is that after each year, there's 87.5% of the population left after each year, okay, because that's the rate. This is how much it starts with, 2,000, and then this is the rate, 87.5% left each year. So if I want to know how much it's decreasing by, then I actually need to subtract that from 100%. Okay, so I got 100% minus 87.5%, so it's actually decreasing by 12.5% each year. Okay, because remember that rate there, since this is decay, it's decreasing, then the factor here is equal to 1 minus the rate. Okay, so in order to get 0.875, you'd have to subtract 0.125 from the rate. How many people would be alive after 10 years? Okay, so that's just a matter of plugging in 10 into the equation. So 0.875 to the 10th power multiplied by 2,000. So 0.875 to the 10th power. And then multiply that by 2,000. So there will be 526 people approximately after 10 years. Not a lot. Okay, I'm going to continue the rest on the next video.